Chapter 9 is about conic sections, and there are three major objectives to cover. One would be on parabolas and circles, then on ellipses, and then on hyperbolas. And you are probably familiar with the concepts, so in a way there might be a review. But so here this section and the next two examine curves formed by cross sections of cones. That's why they're called conic sections. And these curves are graphs of second degree equations in two variables. So second degree means something is raised to the second power. So here's the conic sections, and you may have seen this before, where you basically have two cones, one on top of the other. And when you intersect a cone with a plane at a right angle to its axis, then we get a circle. If it's not vertical or horizontal to the vertical axis, we get an ellipse. When it's parallel to the side, we get a parabola. And when it's parallel to the axis, we get two hyperbolas. So again, I'm sure you're pretty familiar with that. And so here are the various graphs of the circle and an ellipse, parabola, and hyperbola. So these are the conic sections when they're graphed in a plane. So in section 9.1 we cover circles and ellipses, and then the parabolas rather and circles, and then we cover ellipses, and then the last section 9.3 will be on hyperbolas. Section 9.1 has four subsections. One would be on graphing parabolas, and then to use a distance formula to find the distance between 2 points whose coordinates are known, 2 points in a plane that is, and then to use the midpoint formula to find the midpoint of a segment when the coordinates of the endpoints are known. And then part D is given an equation with a circle, find its center and its radius and graph it, and then given the center and the radius of the circle, write an equation of the circle and graph the circle. Here are two equations of parabolas. The first one is y equals ax squared plus bx plus c. So here the line of symmetry is parallel to the y-axis. In this form, x equals ay squared plus by plus c, the line of symmetry is parallel to the x-axis. To graph the parabola y equals x squared plus 4x plus 7, we select some points for x and y, and we plot them on the xy coordinate plane. And we also find the vertex, and the vertex of a parabola was, the x-coordinate was minus b divided by 2a. So that's equal to minus 4 divided by 2 times 1, or 2, or negative 2. And then when we replace x with minus 2 in the equation here, then y equals 3. So the vertex is minus 2, 3. And since this is an upward opening parabola, this tells us that the vertex is a minimum, which also tells us that there are no x-intercepts, no real x-intercept. The y-intercept is when x equals 0 and y equals 7. So we have 0, 7 as another point. By computing a few more ordered pairs and then plotting them in the xy coordinate plane, we can draw the graph of y equals x squared plus 4x plus 7 with a vertex at minus 2, 3. And by computing a few more ordered pairs, we can plot those ordered pairs and then connect them with a smooth curve. And this is a graph of x equals y squared plus 4y plus 7. Which of course is the reflection across the line x equals y. So that's why the coordinates look somewhat familiar from the previous graph. Next is a distance formula where we have 2 points in the xy coordinate plane. X sub 1, y sub 1 is here, and x sub 2, y sub 2 is here, and d is the distance between the 2 points. And so it's often important to know what the distance is. And so this distance, of course, is y sub 2 minus y sub 1. And this distance here is x sub 2 minus x sub 1, absolute value. And then we can apply the Pythagorean theorem to determine what d is. So here's the distance formula for any 2 points, x sub 1, y sub 1, and x sub 2, y sub 2. It's given by d equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So it's simply an application of the Pythagorean theorem. In this guided solution, we find the distance between these two pairs of points, between 2, 6 and minus 4, minus 2. So here are the 2 points, and so now we compute the distance as d equal to square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So x sub 2 is taken as 4, then x sub 1 is minus 2, so 4 minus negative 2 squared, and y sub 1 is equal to 1, so 2 minus 1 squared. And 4 minus negative 2 is 4 plus 2, or 6 squared. And 2 minus 1 is 1, so it's 1 squared. And 6 squared is 36, and 1 squared is 1. So it's the square root of 36 plus 1, or 37. And that's approximately equal to 6.083. So that's the approximate distance between these 2 points. Next, we have the midpoint formula. If the endpoint of a segment are x sub 1, y sub 1, and x sub 2, y sub 2, then the coordinates of the midpoint are x sub 1 plus x sub 2 divided by 2, and y sub 1 plus y sub 2 divided by 2. In other words, the midpoint is an ordered pair. Another way of saying it is that to locate the midpoint, determine the average of the x-coordinates and the average of the y-coordinates. So here's an example. Find the midpoint of the segment with the given endpoints. So using the above formula, there would be 6 plus negative 3 divided by 2, comma, and 1 plus negative 7 divided by 2, or 6 minus 3 is 3 divided by 2 is 3/2. And so here we have 1 minus 7 is minus 6 divided by 2, and that's equal to negative 3. So that is the midpoint. These are the coordinates of the midpoint. Similarly, for the next part here, we have, for the x-coordinate, we have 10 plus 8, 10 plus 8 divided by 2, and we have minus 7 plus negative 3 divided by 2. And since 10 plus 8 is 18, 18 divided by 2 is 9. That's the x-coordinate of the midpoint. And minus 7 plus negative 3 is minus 10. Divided by 2 is minus 5. So these are the coordinates of the midpoint for number 7. Another conic section we discussed in the beginning of the section is a circle. A circle is defined as a set of all points in a plane that are a fixed distance from a point in that plane. So, in a circle centered at the origin with radius r has the equation x squared plus y squared equals r squared. In a circle with center at h comma k, x equals h and y equals k, and radius r, has the equation x minus h squared plus y minus k squared equals r squared. That's in standard form. So here are the corresponding graphs of the circle. So this one here, circle has been centered at the origin. The equation is x squared plus y squared equals r squared. And when the center is at h comma k, then the equation is x minus h squared plus y minus k squared equals r squared. Our first exercise is find the center and the radius of the circle x minus 5 squared plus y plus 1/2 squared equals 9, and then graph the circle. When we compare the equation of the circle with the standard form of the circle, then we notice that the center would be at h equal 5 and k equals minus 1/2. So in other words, the center is at 5 comma minus 1/2, and r squared equals 9. R squared equals 9, so that means that the radius is equal to 3. And here's a graph with the center of the circle at 5 comma minus 1/2, and the equation is x minus 5 squared plus y plus 1/2 squared equals 9. The next exercise asks us to find the center and the radius of the circle x squared plus y squared equals 64. So that's the standard form of the circle, the first one. So that has its center at the origin at 0 comma 0. And the radius, r squared equals 64. R is the square root of 64, so the radius equals 8. The next exercise is a guided solution for finding the equation of a circle where we are given that the center is at minus 3 comma 1 and has a radius of 6. So we substitute the numbers for h and k. So h equals -3 and k equals 1. So it's x minus -3 squared plus y minus k, and k is equal to 1. We should write this down. H equals -3, k equals 1, so minus 1 squared. And since the radius r is 6, there would be 6 squared. So then there would be x plus 3 squared, minus -3 is plus 3, and plus y minus 1 squared equals 6 squared, or 36. So here we're given the equation of a circle, not in standard form, but we can rewrite that as standard form and then graph the circle. We can write the standard form of the circle by completing the square. So we have x squared plus 2x. So we divide this by 2 squared, that would be 1 squared, or 1. Of course, we have to subtract it also, minus 1. And then for the y part, we have y squared plus y squared minus 4y. We divide minus 4 by 2, that gives us, and square that gives us a 4. We need to subtract that also. So to keep the equation the same. And then here's the plus 2 equals 0. So now for this part here now will be x plus 1 squared. And this will be y minus 2 squared. And then we have minus 1 minus 4 is minus 5 plus 2 equals 0. So then we can write this as x plus 1 squared plus y minus 2 squared. And so minus 5 plus 2 is negative 3. Add that to both sides, it's equal to 3. So comparing that to the standard form of the circle, we find that h is equal to 1, to negative 1 rather, and k is equal to 2. And since this is r squared, then r is equal to the square root of 3. So our center is at minus 1 comma 2, and the radius is equal to the square root of 3. Here then is a graph of our circle, x squared plus 2x plus y squared minus 4y plus 2 equals 0, with the center at minus 1 comma 2, and the radius square root of 3. This is the end of section 9.1.